Welcome back, learners. In previous part we had discussed about the synthesis of some important dyes. We have discussed there synthesis of Congo red, synthesis of methyl orange and synthesis of methyl red. And as I told you in the previous part, the dyes are chemical substance or organic compound which are chemically bonded to the substrate or chemically bonded to the fibers, chemically bonded to the papers, to the leather, to the cosmetics. And due to increased demand of the dyes after industrial revolutions, scientists or chemists researched or proposed many synthetic methods. By using that synthetic methods, we can synthesize the dyes in large scales. So, this is a indigo cake and it is a blue color dye. Learners, this indigo cake or this indigo dye is in dark blue crystalline powder, and that dark blue crystalline powder sublimes at 390 to 392 degree, and this indigo molecule absorb light in the part of spectrum lambda max 613 nanometer, and it is a orange part of spectrum. Learners, this deep color of indigo dye is due to configuration of double bonds. Learner, this is the first dye which is low oral toxicity in mammals. So, I am talking about these are the characteristics of indigo dyes which we can obtain from the plants, right. So, the dyes, indigo dyes which we get from the plants are low oral toxicity, and also this is biodegradable. Learners, most indigo produced today in synthetic form, and it is associated with the production of denim cloths and blue jeans. Indigo dye is not soluble in water. On reduction, it converts indigo into white indigo. White indigo is a colorless form of indigo dye which is also called leuco indigo, and that combines with oxygen in the air and reverts to insoluble and penetrate into the surface of the textile and leaves the color. This is the indigo. These are the synthetic methods of the indigo dye. Learners, it is around 1858 the scientist Victor Bayer who proposed some synthetic method from which we get synthesized the indigo, and here you can see this is the first method he used to synthesize indigo in laboratory or in the large scale. Indigo here, when react with sodium thiocyanate and base, we get leuco indigo tin. Leuco indigo is a colorless form, right. So, this is a colorless form. When this leuco indigo or the fabric which dipped in a indigo is taken out from the vessels or taken out from we have to take out into the air, oxidation takes place, and after oxidation it reverts to the indigo and imparts the blue colors. Now, synthesis of indigo, here this is the first synthesis, isolatine, and this isolatine when react with PCl5, phosphorus pentachloride, we get indigo. Similarly, this is another synthesis, and it is also proposed in 18s, and it is used here in this synthesis he used cinnamic acids. So, cinnamic acids to orthonitrocinamic acid, then its oxidation takes place, bromination takes place, and that after that the brominated product we get hydrobromination, dehydrobromination, and after that we get indigo. So, learners, this is a very long step process and it is not economically feasible, and we cannot obtained, we cannot synthesize the indigo in the large quantity. So, another important synthesis by using we can obtain indigo in large scale is from aniline. This is the multi-step process. By using this process, by this synthesis, by these steps, we can obtain indigo in large scale. So, this is an industrial method. From aniline we get indigo, synthetic indigo on large scale. Learners, 1905 the Adolf Beer received that Nobel Prize for his work. So, this is a very important synthesis from aniline. By using that aniline we get indigo, or we can say synthetic indigo. Learners, another important synthetic dye, that is anthraquinone dye. Anthraquinone is a group that you are looking on your screen. This is a anthraquinone and it is derived from the anthracene. Anthracene having a 3 benzene ring, and in the middle benzene ring there is a that carbon is attached, bonded to 2 oxygen atom. So, this is anthraquinone. That anthraquinone is derived from anthracene. And learners, this is the abundant groups of dyes which are having anthraquinone unit, and for getting the color from this dye, from anthraquinone dye, we use mordant. Mordants are the chemicals which is used for deepening of the color, which is used to find out the good quality of color to the fabric. One important type, this anthraquinone type is alizarin. Earlier this alizarin were extracted from madar plant. It is a plant, and from that plant, root of that plant we get this alizarin dye. Now, what is the synthesis or synthetic method of alizarin? Alizarin, anthracene convert into anthraquinone. We get alizarin from anthracene. First part of the synthesis is anthracene converted into anthraquinone, and then oxidation takes place. Oxidation takes place in presence of potassium dichromate, and in presence of sodium carbonate and sodium hydroxide we get alizarin dye, and alizarin is a yellow in color. So, you can see on your screen these are the these are the steps by using which can obtained, which can synthesize alizarin. So, this is the method. First anthracene, oxidation takes place, we get anthraquinone, bromination takes place, added to bromo group, and that when we react with KOH or any base we get alizarin. So, you can see anthraquinone. In anthraquinone there is only quinoid structure, but in alizarin we add, after that reaction with base, addition of 2 OH groups takes place, right. So, there is a 2 OH group which act as a oxochrome. Oxochromes are responsible for the deepening of colors. Learners, how we get a different colors from alizarin using mordants? So, mordants can be aluminum, when we use Al, aluminium, we get a red color. When we use Ca, we get a purple red color. When we use chromium, we get brown violet color. Similarly, when we use iron as mordant, we get black violet color. For stannous, we get red color, and also these are the oxidation. In different oxidation state, we get a different color. Stannous in second oxidation state, we get a red color, and in 4 oxidation state, we get a violet color. So, what is the role of these mordant? Mordants, learners, react with oxygen, one from the alcoholic group OH group and one from the quinone forms. Chelation takes place and that absorb to the fiber of the fiber and covalently attached to the fiber. So, that is why it imparts color to the fibers in presence of different types of mordants. So, for using different type of mordants, we get a different colors using with the alizarin. Learners, another important class of synthetic dyes are triphenyl methane dyes. These triphenyl methane dyes are extremely brilliant and intensely colored synthetic organic dyes. They are having wonderful colors. They imparts the beautiful colors on the fabrics. So, all the dyes are intensely colored, and these are another important class of synthetic dyes. They contain triphenyl methane. So, this triphenyl methane is a backbone of these triphenyl methane dyes. This is the triphenyl methane. So, you can see it is a backbone of these dyes. Triphenyl, here 3 phenyl ring is attached with each other. First example, this triphenyl methane dye is methyl violet. It is also synthetic dye. It belongs to triphenyl methane dye group. So, it is also called gentian violet blue, crystal violet, and it is used as a purple dye. So, especially impart purple color for the textile or used as a ink and also used in paint also. So, this is the characteristics of methyl violet dye, and it is also used as hydration indicator for silica gel. This is the structure of crystal violet color. So, this crystal violet color impart purple color to the fabric. So, this is triphenyl methane and having N-diethyl and 3 nitrogen which is attached to 2Cl group. Another important class of dyes, that is malachite green. Learner, this is a basic dye, and this malachite green traditionally used as a dye for materials such as silk, leather and paper. This malachite green first prepared by Hermann Fischer in 1877 with benzaldehyde and dimethyl aniline. So, he has taken this benzaldehyde and dimethyl aniline into in 1:2 ratio, and the reaction takes place in presence of sulfuric acids. So, this is, you can see it is a as by the name it is in green in color. So, condensation of benzaldehyde and dimethyl aniline takes place and we get a leucobase which is a colorless, and when it's stabilized we get a green color. So, that leucobase convert into green colors. So, this malachite green is very important dye and imparts green color to the fabric. So, this malachite green is moderated with the tannin, and learners, it is banned in Europe and US for its carcinogenic nature, and also it is tetragonyl effect. So, due to its tetragonic effect and due to carcinogenic nature, it is banned in Europe and US. But this dye being is cheap and is persistently used in various countries, and this dye is also used for fishing farming also, and this is also called aniline or China green dye. And learners, it is used to control external fungal and protozoan infection of fish since 1933, but it is not used for veterinary drug for use to food fish. This is malachite green. You can see the structure of malachite green, and here malachite, how the malachite green convert into leucobase. Leucobase is colorless base, and when this leucobase is treated with HCl, we get a color base, and that color base is due to extensive conjugation. Extensive conjugation takes place from N methyl group within the ring. So, due to that extensive conjugation, malachite green is colored dye and imparts color to the fabrics. So, here this is a leucobase. This leucobase on oxidation in presence of lead oxide and HCl, we get a carbon ion, and that carbon ion is colorless, but when we add excess of HCl, excess of acid, we get malachite green. So, this is a way, this is the method, synthetic method, we can synthesize this malachite green on large scale. The color, green color of dye is due to delocalization of electrons. So, here extended conjugated system takes place. Due to this extended conjugation, due to a delocalization of within the extended conjugation, we get green color of this dye. Another important class of synthetic dye is rosa-aniline dye. Rosa-aniline dye is a basic dye. So, it is also called magenta dye, and it is most famous aniline dye, and it is commercially produced from the aniline used as fungicides, fabric dye and ink colorant. This is also used as a, this is also fluorochrome dye. What is the meaning of fluorochrome? When we keep or we kept these dye in a presence of in the sunlight or in photons, the excitation takes place. So, excitation wavelength of 572 nanometer, which appear in the green color, and emission wavelength of 625 nanometer. So, that is why we called rosa-aniline is a fluorochrome dye also. This is a structure of rosa-aniline dye. This is the chemical structure. So, you can see here, this is triphenyl, and that triphenyl methane having OH and NH2 group, right. So, this is the basic backbone of rosa-aniline dye. We get 3 aniline group, you can see on your screen, 3 aniline group which is bonded with a carbon which having OH group. So, this rosa-aniline dye is a very important dye, and we can synthesize this dye on the large scale. Now, how we synthesize this rosa-aniline dye? As I told you, this is also called aniline dye, right. So, when aniline react with orthomethyl aniline. So, orthomethyl aniline react with aniline and paramethyl aniline, and when we add any oxidizing agent, right. So, when we add any oxidizing agent, here is a nitrobenzene, you have nitrobenzene, we have used nitrobenzene. So, we get a leucobase. As I told you, leucobase is a colorless base. How that leucobase of rosa-aniline dye convert into colored form? So, leucobase when react with lead oxide, we get a colored base. Similarly, when we add excess of HCl, after adding excess of HCl, we obtained rosa-aniline dye. So, this is a very important synthetic method for the preparation of rosa-aniline dye. So, in rosa-aniline dye, you can see the 3 benzene ring, and that 3 benzene ring attached with a carbon which is covalently or bonded to the bonded each other, one is double bond, other is a single bond. Now what is the reason why we get a colored due to from this rose aniline dye? So color of dye is due to delocalization of electrons. So or we can say, as I told you in the previous part, the color of dye is due to presence of chromophore and oxochrome. So basically the chromophores are the groups which impart color to the fabric. That chromophore can be nitroso group, can azo group, can C double bond C, right, can C double bond N. So these are the chromophore groups, but oxochrome groups are NH2 groups, right. So due to that chromophoric group, extension conjugation takes place, and due to that extended conjugation we get colored dye. So in the structure you are looking here, the resonating structure of that rose aniline dye, and we are getting here 3 resonating structure. So due to that extended conjugation we get a color. This is green metallic color we obtain. A solution in water we obtain violet color. This is also called magenta dye. So when we add here SO2, SO2 is a oxidizing, we act as an oxidizing agent. So when we add SO2 sulfur dioxide, we get a colorless Schiff reagent. So due to that this dye is used for qualitative detection of aldehydes. So we can use this dye as in qualitative detection of aldehyde, or for use industrially dyeing the material also. Another class of that synthetic dye is para-rosaniline dye. So this is also class of synthetic dye. We had discussed rose aniline dye, and now this is a para-rose aniline dye. What is this dye? This is a basic dye, right. So this is a basic dye used as a direct dye for a wool or silk. So what is the meaning of direct dyes? These dye can be applied directly on the fabric. So especially this dye is used for dyeing the wool and silk. Now how can we synthesize this dye? This dye para-rosaniline dye is also synthesized by the condensation of aniline, 2 moles of aniline plus para-methyl aniline. So 2 mole of aniline plus 1 mole of para-methyl aniline, when react with nitrobenzene we get leucobase again. So there is a leucobase. Leucobase is a colorless base of para-rosaniline dye. So when this para-rosaniline dye react with any oxidizing agent, so oxidation takes place, and after oxidation we get para-rosaniline dye. So in the structure you can see here 2 molecules of aniline react with methyl aniline. So when this methyl aniline react with nitrobenzene we get a leucobase. So in leucobase you can see here the internal carbon, the carbon which is bonded to 3-phenyl ring is having CH, and when this leucobase, which is a colorless base, react with PbO2, lead oxide or HCl, we get a color base, and if we add excess of acid we get a color dye. So this is a rose aniline dye. What is the reason of this? Why this color, this para-rosaniline dye gives the colors? Colors is due to the extended conjugation. So color is due to delocalization of electrons within the ring, we get a extended conjugation. So here you can say here this is a para-rosaniline dye, and again which type of chromophore is here? You are looking here 3 benzene ring, one is having NH2 and double bonded carbon atom. So from NH2, from nitrogen atom, the non-bonding electrons delocalized with all 3 rings, and due to that delocalization we get a carbonium ions. So, in the second structure you can see here the carbon which is act as a carbonium ion. So, again delocalization of electrons takes place and we get a third resonating structure. So, due to this extensive conjugation we get a color which impart the color on the molecules. So, as I told you learners, regarding the synthetic dyes are very economically very cheap. We can synthesize in our laboratory as well in industrially. The peoples who are associated with the colored industry, they can synthesize on the large scales. So, and some dyes are carcinogenic, and that especially azo dyes are very harmful for our skin, and some countries ban these dyes. Learners, another important synthetic dyes is a crystal violet dyes. Crystal violet dyes is also basic dyes, and this is in violet color. We also call methyl violet 10B or hexamethyl para-rosanilin dye. It is also a group of triaryl methane dye. So, this dye is used in textile industry, dye paper, and it is in a navy blue color, and black ink for the black ink for printing, and inkjet printers used to differentiate between gram positive and gram negative bacteria. And gram staining, this it is a method used in microbiology, and this is a structure you can see here. Crystal violet binds to some amines, some proteins, and it gives the color to the cell. It gives the purple color to the cell, and on the basis of that we can classify the bacteria, which bacteria is in that he bind to the proteins. So, this is the crystal violet. It is also triphenyl methane dye and having and CH3 groups, and it is synthesized by NN dimethyl aniline plus carbonyl chloride in presence of aluminum chloride. So, this is a method by using which we can synthesize this crystal violet, and in the solution it is violet color with pH color of crystal violet change. Learners, here again this is the crystal violet. When acid solution it convert into green color, and in basic solution it convert into yellow colors. Another important class or last class of dye is phthalate dyes. Phthalate dyes are acidic dyes, and it is mainly used as a pH indicator due to their ability to change color. It is used in acid base titration, and common phthalate dyes are chrysophthalate dyes, which is used medically to determine the calcium level of human body, and this is the phenolphthalein. We are also called pH dye. It is used acidic or colorless. In acidic solution it is colorless, or in basic solution it is in pink color. And this is the last thymol phthalate dyes, and this is also class of phthalate dyes. So, learners, in this part we had discussed some important methods of synthetic dyes which can be used in large scale in the industry. Learners, China is the first exporters and manufacturers in the world, in the globe, after the India, and other countries after India, as India is the second largest manufacturer and exporters of dyes, followed by US, Brazil and UK. So, these are some important dyes which we have discussed today in this lecture. Thank you.